Back in January this year, we felt the need to explore the capabilities of SAP IBP demand sensing to improve our forecasting processes. So as I had worked very well with Ashutosh from GitaCloud in the past, I chose to work with him together with SAP on a demand sensing pilot co-innovation. Now let me turn to Ash to describe the good work that he has done for us. All right, Ash.
Okay, thanks, Anthony. That was great. So let's just, and I hope folks can still see my screen. So let me just walk you through this journey. Since the start of the year, we took NVIDIA's data, their bookings, their shipments, their forecast from a sales perspective, demand planner perspective, and we tried to come up with a forecast in the demand sensing horizon over the next 6 weeks. We also tried to understand the quality of the forecast and the improvement IBP sense demand could deliver. And we were able to demonstrate a high quality forecast, more accurate forecast. So that generated interest in moving into phase 2 of this journey. And in the phase 2, we moved the focus from demand sensing 6 weeks to a full next 4 quarters forecast, which is how the demand forecasting process is set up to run. We took the same view that we had for the demand sensing phase 1 and now moved into midterm demand forecasting mode for the entire data scope, all the SKUs in that view. We also expanded the scope now outside IBP, so not just within IBP gradient boosting and ARIMA and auto exponential smoothing, all the models that come within IBP. But we also went out and looked at NVIDIA's Kratos platform as a GPU compute acceleration. Keep in mind that the co-innovation was on 2 dimensions. One was the solution quality to say how good a machine learning forecast can be compared to what we have. Second element of that was to say what kind of acceleration to the forecast run times can GPUs provide. And there are use cases in demand shaping, demand optimization, demand simulation, where the speed of forecasting becomes important to the business user. So we also took NVIDIA's Kratos platform, which is a GPU-powered compute in the cloud, and deployed some of our machine learning models, and I'll talk about them in a second, on that platform. We also took GitaCloud forecasting service and user forecast. So essentially, we brought together a lot more forecast candidates, if you will, and the data scope than we had in phase 1. And this is also the phase in which we did this innovation for touchless forecasting to say when you have a lot of competing forecasts, how do you find the highest quality forecast, SKU by SKU, quarter by quarter. Just to give you a sense of potential next steps, where we go from here, we could be doing any of those things, data integration with SAP ERP to operationalize the phase 1 demand sensing and the phase 2 demand forecasting pilots. Ingesting more driver data into the machine learning models. So taking ASPs, for example, macroeconomic data, channel sales and inventory. We found some data quality challenges, as you can imagine, with external data. So we are trying to also look at how to address those challenges and from a data collection frequency perspective. And sometimes you can have good data from the channel, not from the OEMs and all that. So we have to address that. Also, we're going to test some more models, especially focus on the deep learning side of models, not just machine learning. Bring in ASP as a driver, so start to understand the ASP elasticity curves to this kind of demand optimization pilot to say it's not enough to just say, well, I have a certain revenue guidance, let me now figure out one way of matching to that revenue number, but really saying, well, given the supply constraints, given the ASPs, what would be the best unit level forecast, and knowing that ASPs are going to impact, especially in product transitions, how to take that into account. And of course, touchless forecast value audits to say not just go on faith basis. We have demonstrated high quality, but does it sustain? And are we on a continuous innovation improvement track to continue to reduce the error? So let me, with that, take you into the actual guts of the touchless forecasting innovation. I just want to paint a picture of, before we say what it does and how it does it, let's address the question, why do anything in this space at all? And Anthony, thanks for outlining some of the challenges NVIDIA demand forecasting process and demand planners have communicated. We talk to many customers in this industry and outside, and we hear sort of many flavors of problems when it comes to demand forecasting. So I wanted to paint a few here. One is, in general, the moment you're talking about granular SKU or SKU location levels, the forecast error is quite high. So of course, at a management measurement level, if you're looking at BU level numbers or technology portfolio level numbers, those numbers look somewhat decent. But if you keep exploring it down to say, well, how are SKUs doing globally, how are SKUs doing from locations perspective, or by large end customers, you suddenly see the forecast quality degrade quite a bit. So traditional forecasting approaches, just to do some kind of forecast extrapolation with exponential smoothing, what we used to refer to as univariate forecasting, that is no longer effective. Just too much fragmentation and volatility given the last couple of years of the pandemic here. So that is a general common theme we hear, that the forecast isn't delivering the quality that is expected for supply chain perspective. We also, and Anthony referred to this directly, the process starts bottoms up somewhat from sales and statistical forecasting perspective. You bubble it up to the executives and say, well, this is the kind of revenue we forecast. And obviously you get a different guidance back. And now the challenge becomes how to disaggregate that down accurately back to SKUs. And you can take a 10% uplift to the total revenue and apply 10% uplift to all the units. It doesn't work cleanly like that, because some SKUs may not have bookings, some may have supply constraints. So it becomes a problem of distributing in a feasible manner. There is also a general challenge we heard from some customers saying, well, they are doing things a certain way, forecasting at a certain level, but they don't know if that's the best level to forecast at. So there's no ability to sort of every forecast cycle pretty much test all the levels and figure out which level is the most forecastable. And even if you chose a different level, how to then continue to bring that signal down to SKU level in a good way. Some customers, and this is again a very widely varying continuum from an ML adoption perspective. Some customers are piloting the ML right now. Some have gone live with ML for a couple of years in a couple of business units, not across the organization. For customers that have deployed ML and are seeing the results in production over a period of time, they are experiencing a phenomenon called model drift, which means the quality of the ML models start to go down as the in-house data science teams that put it together, their focus moves on to other use cases or other business units. The hyperparameter fine-tuning required doesn't get the sufficient attention it should, and then the model quality starts to go down. In general, and Anthony referred to this again, the processes are not scalable either because the demand patterns are too fragmented now, or number of SKUs. It's just the amount of time given to the demand review step. The planners just don't have enough hours in the day to do justice to all the SKUs in every cycle. There's also a high bias. There is the sales forecast, the marketing forecast. Customers are telling you, finance has guidance. A statistical data science team has a forecast. Demand planners have no effective way to blend all these forecasts at different levels, different granularities, different time buckets, in an unbiased manner, right? It's usually the loudest voice wins, and there's need for a process that can take a lot of, if you will, sometimes the same, sometimes competing, conflicting forecasts, and then produce the optimal blended composite forecast without any bias. So that's sort of the problem side of the house. If you look at how touchless forecasting helps, one, obviously, IBP has made, SAP IBP, made good strides in terms of gradient boosting and other models within IBP, which are machine learning. But there are many, many more models out there, obviously, and SAP is on a journey to continue to bring more models in. But in the meanwhile, our approach is to look at all these models outside. So not just gradient boosting, but cat boost, the category boost inside, some deep learning models like CNN or random forest, Prophet. There's just so much out there. And essentially allow the data to go through all these model pipelines to see which model fits which data seed is the best, and then bring those forecasts back into IBP. So from a business user experience perspective, they're consuming the pick best stat forecast within IBP, nothing changes for them. It's just the quality of the stat forecast. We are making sure it's the best possible forecast. We also look at pretty much every cycle. It's part of our forecasting service, a forecast level and time bucket optimization. So we make sure that the level at which you're forecasting, the time buckets at which you're forecasting are making it the absolute most forecastable time series, and then also figuring out a way to accurately split and distribute that forecast down to SK. As part of the service, we also do machine learning hyperparameter optimization. So for IBP practitioners, they will know this, that you select the gradient boosting model. The tool either has defaults for parameters like number of trees, the max tree depth, the learning rate, and so on. Or you can change them, but essentially you're just shooting darts in the dark. You have no way of knowing what you're setting. There are infinite combinations of these parameters, which combination will provide the best outcome. There's something similar on the auto exponential smoothing side, where alpha, beta, gamma parameters are optimized in IBP, but not on the machine learning gradient boosting side. So this is part of our service to essentially optimize these parameters and produce the best possible ML forecast. From a SKU portfolio scaling, we obviously need the touchless forecast plays a huge role here, where it can take all the machine learning signals, all the human forecasts, and blend them autonomously and optimally. So the scalability and the sustainability of value, those challenges reduce. We also obviously are doing this in a very unbiased way across all the signals. So the composite forecast, or what we call the touchless forecast, has much reduced. So hopefully this gives you a clear sense of the challenges we hear and how touchless forecasting and forecasting as a service helps. Let me just deep dive into exactly the kind of models that we considered in this round phase 2 with NVIDIA. So